In today's lesson, we'll be talking about average rate of change. You already have these notes in your notebook. But what I want you to do first is just simply watch and let's remember some things about rate of change. We did rate of change when we covered linear functions. Rate of change is like slope. Slope is m equals y2 minus y1 over x2 minus x1. It's the change in your y's divided by the change in your x values. So, let's find slope between these 2 points. This is an x, this is a y. I'm going to assign this to be x1, y1. Therefore, this is x2, y2. So we'll simply plug it into our formula. M stands for slope. The formula has a subtraction sign in it. y2 is 7. y1 is 2. x2 is negative 6. x1 is 4. Now you have a few options here. You can either work this out or you can type it in your calculator. 7 minus 2 is 5. Negative 6 minus a 4 is a negative 10. With slope, you have to get it in its simplest form. 5 and 10 both divide by 5, so I'm going to divide the numerator by 5 and the denominator by 5. 5 divided by 5 is 1. Negative 10 divided by 5 is a negative 2. So my slope is a negative 1/2, meaning that between these 2 points, it decreases by a rise of 1 and a run of 2. It's going to go down 1, your graph wheel, and to the right 2. So far, you've only done slope with linear functions. When you look at a linear function, it's a line. I've graphed this line, and I've already darkened the exact points. To go from one point to the next, I will go down 2, right 1. To go from here to here, I'm still going down 2, right 1, down 2, right 1, down 2, right 1. Since I went down 2, right 1 every time, I have a slope of 2. When the slope is the same everywhere on your graph, it's called a constant rate of change. Linear functions will have a constant rate of change. Now, if you're wondering where you're supposed to be writing this down, you're not. You're simply watching and listening. But what our section is about is quadratic functions. Quadratic functions are our parabolas. When you look at this parabola, here's your vertex, because that's the lowest point. And remember, it's the lowest point is also a minimum. But we're not talking about features. We're not talking about graphing this quadratic. We're talking about the rate of change. I want you to look from this point to this point. From here, the vertex, you would go up 3, right 1. Up 3, right 1. Well, that's a positive 3 over 1, which is 3, between these 2 points. But if you look from the vertex to this point, you will go up 3, but left 1. Up 3, left 1 is a 3 over negative 1, which is a negative 3. Negative 3 is not the same as a rate of change of positive 3. Let's look from this point to this point. You would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and to the right 1. Up 9, right 1. Positive 9 divided by 1 is a rate of change of 9. These points have a rate of change of 9. These have a rate of change of 3. Between these points have a rate of change of negative 3. Because all of these rate of changes are different, they are not constant, and we say that a quadratic has a variable rate of change. Variable meaning it can change. So just because you find the rate of change between these 2 points, do not assume that that is the rate of change for every set of points on this quadratic function. It's not. Now, I want you to turn to page 68 of your notes. That's where you'll find the rate of change, average rate of change of quadratic function notes. At this point, you will begin to write down the average rate of change of a function is the change between any 2 points on a function. It is the measure of how a quantity changes over some interval. Now, you noticed when I showed you the quadratic function had a variable rate of change, I had to indicate which 2 points we were looking at. What is the interval that I'm focused on? Recall, here's the slope formula again for you. y2 minus y1 over x2 minus x1. Delta means change in. That's how you get your rise. You're changing in your y. You're changing in your x as you run. You'll use the same formula to find the average rate of change over a given interval. Now the next part is really about when you're going to describe or you're going to compare two different functions and their rate of change. When describing and comparing the average rate of change, positive and negative simply tell you the direction of the graph. A positive rate of change tells you that the function is increasing. It's going up, it's positive. And a negative rate of change tells you that the function is decreasing. This will be important in the future. Right now, we are simply going to attempt to learn to calculate rate of change for example 1. So in example 1, it says that we are to calculate the average rate of change for this function. This is the function that I'm looking at between these 2 points. So it's like if I'm looking at a graph, I'm only looking between when x is 1 and x is 3. Well, I have a problem here. I know what x is, but I need the y's. So the first thing I've got to do is find f of 1 and f of 3 to get my 2 points. So f of 1, everywhere I saw an x, I'm going to put a parentheses. And because I need to know 1, I'm going to plug in 1 first. Hopefully by now you are an expert at plugging this in your calculator. That's what I'm going to do while you write this down. 1 squared plus 6 times 1 plus 9. I get 16. This is your x. What you get out is your y. So your ordered pair is 1, 16. Now you do the same thing with f of 3. You take your parentheses. Everywhere there was an x, you completely replace it with 3. I will type it in my calculator. All I have to do is go back in and change those 1s to 3s. I found that it's 36. If you plug in an x and you get out a y, there's your ordered pair. The ordered pair is 336. Now you're ready to do rate of change. You're going to use y2 minus y1 over x2 minus x1. x1, y1, x2, y2. The formula has a subtraction. y2 is 36, y1 is 16. x2 is 3, x1 is 1. Now I'm allowed to use my calculator here if I would like. I just type the whole thing in the way I see it. It gives me out an answer. 36 minus 16 is going to be 20. And 3 minus 1 is going to be 2. And hopefully you know that 20 divided by 2 is going to be 10. So your average rate of change between x equals 1 and x equals 3 is 10. Now let's move on to example 2. Example 2 shows us a graph. It says, use the graph of the function to calculate the average rate of change between x equals negative 3 and x equals negative 2. Well, what you're thinking right now is, oh my goodness, there's no function. I can't plug this in. I don't know the function. I can't plug in x and get my y. You are looking at your x's and y's. every point on the graph is an x and a y. All you have to do is find where is x equals negative 3. Now you have to be careful with this graph. Here's your 0. This is 1. Every 2 is where you move. Negative 1, negative 2, negative 3. Well, how do you find your y value? You go up until it crosses. Now this is not 1, 2, 3, 4 because every 2, this is 1, 1 and a half, 2. So this ordered pair right here is negative 3, 2. So your first ordered pair is negative 3, 2. Now you need to find the y value for x equals negative 2. This is 0. This is negative 1. This is negative 2. Well, where's the graph? It's right here. That's not 1, 2 because of how the graph is done. That is 1. This is the point negative 2, negative 1. So here are the 2 points that you're trying to find the slope between. You have 2 options. You can count the rise over the run, or you can plug it in. You fall. Since I go down, I know it's going to be negative. I go down 1, 2, 3. So I went down 3. I go to the right 1. Well, if I go down 3, right 1, 3 is negative, 1 is positive, negative 3 over 1 is a negative 3. That's my rate of change. Well, let's say that you didn't see that, or you didn't understand that. You want to use the formula. Here's the formula. y2 minus y1 over x2 minus x1. I'm going to plug these in. x1, y1, x2, y2. y2 is negative 1 minus y1 is 2 over x2 is negative 2 minus, because it's in the formula, negative 3. Now what do you know about minus and negative? Minus and negative is the same as plus a positive. So you have negative 1 minus 2, which is a negative 3. You have negative 2 plus 3, which is 1. Negative 3 divided by 1 is a negative 3. I want you to notice what we got both times. Both times we found that the average rate of change over the interval x equals negative 3 to negative 2 is a rate of change of negative 3. I did this by looking at the graph and counting rise over run. I did this using the formula. Either way gets me the same answer. So when you see a graph, you're welcome to choose either way. What I want you to do right now is I want you to try example 3. Example 3 gives you a function. This is the entire function. Don't forget the minus 2. Find the average rate of change if it's greater between these 2 intervals or these 2. Since I give you 2 intervals, you're going to need 2 rates of change. Now this video is going to end, and when you get finished with example 3, I want you to start part 2.